Welcome everybody to Embedded World 2022. We are very happy to be back again in Nuremberg. So this year it's again all about system design enablement, and we have prepared various demos for ultra low power always on solutions, also AI-based edge processing, then various audio demos, true wireless audio, but also a smart hearing aid device based on a 22 nanometer SoC, and last but not least, also system analysis tools for thermal and EM simulations. So please watch our demos and enjoy the fair.
Good morning, everyone, and welcome to Embedded World 2022. I'm Amol Borkar. I'm the Director of Product Management Marketing for the Tensilica IP business in Cadence. Today, I'd like to show you a demonstration from one of our customers, Black Sesame, which features our Tensilica IP. So we have a Black Sesame platform over here featuring the A1000 SoC, which has 4 Tensilica Vision P6 DSPs on there, along with their own ultra high performance neural network processor, or the NPU. Our Tensilica Vision DSPs work in conjunction and collaborate very well with this NPU from Black Sesame, which is their own proprietary IP. As part of this demonstration, I'd like to show you some real-time ADAS applications. So you have a front view, a back view, right view, a left view, all doing real-time analytics, detecting the vehicles, detecting boundaries of where the vehicles are, and then we are combining these images over here to create this bird's eye view around the vehicle. And at the same time, also doing real-time parking analysis and telling you where there are parking spots around the vehicle. Some of these applications are running purely on the Vision P6 DSP, or in some cases, it's doing the AI pre-processing and post-processing on the Vision P6 DSP, and then some layers of the neural network that may not be able to run on Black Sesame's NPU are offloaded to the Vision P6 DSP. So as I pointed out over here in this particular example, the Vision P6 DSP works very well in conjunction with Black Sesame's NPU. If you'd like to learn more about this, please visit us at ip.cadence.com. Thank you.
Hello, my name is Eric Skup from DSP Concepts. I'm in charge of the global sales organization, and we're here at Embedded World 2022 in the Cadence booth. So DSP Concepts is a company that builds a software audio platform to allow users to leverage the audio of things, bringing audio functionality to all kinds of types of devices. Anything with a microphone and a speaker, we provide a comprehensive platform to bring in functionality. Here in the Cadence booth today, we're showing our true wireless stereo offering running on the latest HiFi 5 DSP from Cadence. This DSP is very powerful, has a lot of audio functionality, and more and more people want to bring in more features. So today here we have the Aroha AB1585, which is one of the first TWS chips with a HiFi 5 to hit the market. Our platform is running connected directly over Bluetooth to the device. It allows you to bring in all your audio functionality, profiling, and optimizing the power of the HiFi 5 directly with a simple platform. So we have an ecosystem of third-party functionality and optimized code. So together between Tensilica and the DSP Concept software, product makers can focus on innovation as we bring in the DSP power, the optimization, the functionality to market for an easy go-to-market functionality. And if you want more information, please go to www.dspconcepts.com. Thank you.
Hi, my name is Jens Kamau. I'm a PhD candidate from the Leibniz University in Hannover. I'm currently working at the IMS, the Institute of Microelectronic Systems. In our cooperated project, the Smart Hearing Aid project, we aimed to design a new hearing aid processor. The goal of our project was to develop a high-level programmable mixed signal SoC which enables wireless connectivity for future hearing aid. The main processor in our new SoC is a customized Tensilica Fusion G6, which we extended with a Thai instruction language. At the end, we want to enable high-level programming, high-level algorithms on the new developed SoC. At the beginning, we started with a virtual prototype environment from Cadence to design partly the algorithms and also the software, so kind of do a hardware-software co-design for developing already the algorithms and the hardware and bring it together. After the tape out, we developed a bring up board with our partners to implement the first drivers and the bring up of our chip. Furthermore, we then set up the connection to other peripherals to integrate it in a full hearing aid. This you can see here in the foldable PCB. In this PCB, we added, beside our new developed SoC using as main processor the Tensilica Fusion G6, we also used interfaces for Bluetooth, near-field communication from ear to ear, and power management and stuff like this. At the end of the project, we integrated everything together into a real hearing aid demonstrator, which can be used for research on patient studies. So the main processor in our chip is a Tensilica Fusion G6, which was extended with several instruction extensions.
Longo Technologies is a developer and licenser of software DSP technologies that's ported onto HiFi Tensilica cores. Today we're showing at Embedded World our PATRA, Personalized Amplification Transparency. So PATRA can be ported onto any type of hearable like TWS, headphones, or neck bands, and it allows a personalized experience of hearing for the person using the product. So this is really for headset OEMs. So with PATRA, the person can go through a self-test that's quite simple and quick to characterize the hearing in both their left and right ear. And then those parameters are used in our custom algorithm so that the person experiences personalized hearing. So the technology is made up of the self-test, the acoustic feedback cancellation, noise reduction, and then dynamic range compression, which provides personalized hearing experience. So we're demonstrating our technology today at Embedded World on Tensilica HiFi core, and a person can experience what it sounds like for different environments and different settings, whether it's emphasizing low tones or high tones or just across the board. So that's our demonstration, along with other voice enhancement technologies for improving phone call performance, hands-free performance for headphones and TWS products. So please come learn more at www.alango.com.
Good morning, everyone, and welcome to Embedded World 2022. I'm Amol Borkar. I'm the Director of Product Management and Marketing for the Tensilica IP within Cadence. Today, I'd like to show you one of our newest Vision DSPs from our Vision family of products, which we call the Vision P1 DSP. It's a fully functional, fully capable Vision DSP, and along with all the great features of a Vision DSP, it is also targeted for ultra-low power, always-on type of usages. In this particular example from the Vision P1, I'd like to demonstrate two particular examples, all AI-based networks running on a TinyML or TF-Lite micro framework. So I have one demonstration for human presence detection, which is doing visual wake word spotting. So here we're doing presence detection, and as you can see, if I walk near the camera, it shows me that a human person has been detected and is present in the scene. Aside from that, we are also doing another AI network, which is called keyword spotting, which is to determine if somebody has spoken something within the environment. So this network is tuned to recognize a couple of keywords. So things like up, down, left, right. So as you can see, one of the big differentiations over here between the Vision P1 and a lot of the IPs out there is we can run both audio as well as vision or camera-based always-on networks and workloads simultaneously on one piece of IP rather than having separate IPs for different workloads. If you'd like to learn more about this, please visit us at ip.cadence.com. Thank you.
Hello, my name is Srdjan Đorđević and I'm working for Cadence out of the Munich office. So today I will show you our brand new tool which is called Clarity Transient Solver. So why is the Transient Solver very important compared to our Clarity Finite Element Solver? Because our Transient Solver is there as a global type of the solver which is used for very big geometries. I will show you today example where I have a PCB inside of the chassis, and if I would like to mesh this everything with a fine element solver, this could be a problem with the resources of the computational power. Here I need to see the problematic about the leakage of the energy from the PCB through the mechanical holes, and I would also like to optimize the design of these mechanical holes. So what I'm basically doing, I'm forming source, noise source inside of the chassis, which is sitting at the PCB level. And what I'm also doing, I'm putting basically the planes which will capture near field, and then I can inspect them and look at the fields which are leaking out of the chassis and trying to find the real pattern and to optimize these mechanical holes. So what I can show here also, I can pick up the appropriate mesh in order to really address these mechanical holes. You can see here that I can work with very fine mesh, which is 0.04 millimeter, or I can relax mesh with a 0.4 millimeter. So for finer mesh usage, I definitely need more memory and computational power, and the GPU introduction is essential, and this GPU introduction is very well supported in our Transient Clarity tool. So in this example that I showed here, in these results, what you see here, I'm using 2 millimeter mesh. It's a first order of the mesh, but it's 20 minutes of the simulation on my laptop, and I'm definitely seeing immediately, including complete PCB, mechanic of the PCB, including complete mechanic of the chassis. I can see critical positions on the chassis with the leakage field. I can measure this near field here and also look at the directivity over there. So that means you can use it as a very powerful first order assessment tool. So let's say with a not really fine mesh, and then if you want to use fine mesh and more accurate response, then you will need to introduce a GPU as I showed here. So very easy to use, very easy to set up the simulation, and really very good solution for big geometries like PCB plus chassis optimization. If you're interested for more information, please contact us and look for the more information on www.cadence.com. Thank you.